Alright, so if you really see, one of the reasons why we study mechanics is we want to understand motion. We want to be able to describe motion. We would like to predict motion. For example, if you give me the position of an object right now, I should be able to predict the position after some time. So in cases where acceleration is constant, meaning acceleration is not changing, meaning in equal intervals, velocity changes by equal amount, like the case of free fall we saw. There, every second, velocity changed by 9.8 meters per second. So in those cases, if you're given values of some parameters which describe motion, we have some equations that we can use to find other parameters or find missing information, which kind of completes your description of the motion. And that is what we're going to study today. Very important to note that what we're going to study today is applicable only for constant acceleration, right? So now let's get started. So in case of your constant acceleration, the average acceleration would be equal to your instantaneous acceleration. As you can easily see, in case of free fall, you try to find average acceleration between any two time intervals, you would find that to be equal to 9.8 meter per second square, right? So now an object starts from here to here, velocity changes from u to v, acceleration would be what? Change in velocity divided by change in time, v minus u by t, assuming you start at t equal to 0. You rearrange this, you get v is equal to u plus at. And that would be fairly intuitive, that your final velocity is equal to your initial velocity plus a multiplied by t, acceleration multiplied by time. Final velocity is equal to whatever velocity you started with plus how fast your velocity was changing, that is acceleration, multiplied by how long velocity changed, that is time, right? So here the value of a can be your average acceleration, or in case of constant acceleration, it would be instantaneous acceleration, right? Now when a is constant, the average velocity, that is equal to initial velocity plus final velocity divided by 2. Very important to note that this will not hold good if acceleration is not constant. Like this equation still holds good if acceleration is not constant. All you have to do is, for a, you have to use average acceleration. This equation will not hold good if acceleration is not constant. So please keep that thing in mind. So now with this information, you can find the displacement after some time. That would be your initial position, initial displacement plus average velocity into time. And average velocity we found from here is u plus v by 2, right? So you can substitute here, you'll get this. So using this, you can find the displacement. Very important to note again, this is x-axis displacement, not the distance. Yeah. So if we ignore the initial conditions, there are 4 parameters of motion. You have displacement, velocity, acceleration, and time. Generally, in the case of uniformly accelerated motion, what happens is that you are generally given the values for 2 of the parameters and you're asked to find the value for the 3rd parameter. For example, you might be given the value of acceleration and time, and you might be asked to find the final velocity, which you can easily find using this equation, v is equal to u plus at. Or you could be given final velocity and time, and you might be asked to find the displacement. And again, you can use this expression to find that, right? So generally, it's convenient to obtain relationship between any three of the 4 variables, 4 parameters. So we have 4 parameters. It's generally convenient to have relationship between 3 of the 4 variables. We already have 2 such relationships. One is this relationship. It has velocity, acceleration, and time, and it does not have displacement. And here you have another relationship which has displacement, velocity, and time, and it does not have acceleration. So to complete our set of equations, we need 2 more equations. One which has displacement, acceleration, and time, and which does not have v, and we need 1 more equation which has displacement, velocity, and acceleration but does not have t, right? To get to those equations, all you have to do is use substitute value of v, this value here. You get one expression which says your displacement is initial displacement plus ut plus half at square. This, as we said, it has your displacement, acceleration, and time, and it does not have v. To get the fourth equation, you substitute value of t from here to here. You get one more equation which says v square is u square plus 2a x minus x0. This expression has displacement, velocity, and acceleration. It does not have t. So now, based on whatever we've seen so far, you have 4 equations, and each equation has 3 of those parameters, 3 of the 4 parameters. For example, this one has velocity, acceleration, and time, and it does not have displacement. And this has displacement, velocity and time, and it does not have acceleration. So depending upon the kind of problem you are given, you can easily pick up the appropriate equation and use that to solve the problem. Other thing is that these are the generic equations. So depending upon your initial conditions, for example, if you're starting from rest, obviously your initial velocity is going to be 0, your initial displacement is going to be 0, right? And you can substitute the values and it simplifies the equations even further. So in that case, v square is going to be 2ax. Similarly, here you substitute x0 and u to be 0. If you're starting from rest, your x is going to be half at square, right? Similarly, in case of free fall, your distance or displacement is in vertical direction. So instead of x, you're going to have y, and your acceleration is in negative direction. So instead of a, you're going to have minus g, and you can pretty much use the same equation, right? So I guess that's pretty much, that's about it. Thank you so much for your time. Talk to you guys next video. Thank you.